It's start. Okay, so we're getting started again. Welcome back. So now we have Charlie from Irish Manufacturing Research. Are you there and able to? I can see your face. Hey.
Can start sharing now. I should be able to see that.
Yeah.
Yeah. Hi everyone. I'm Charlie, Behan from Irish Manufacturing Research. So I'm just going to talk about a project we're involved in, DigiWind. It's an EU-funded project, and just the aspect I'm going to be talking about is a process that we use for creating and showing immersive content. So just a very high-level overview of the project. It involves 9 partners across 5 countries, and the main goal is to train 900 masters and masters in science students and 10,000 industry professionals over a 4-year period. And this is all around wind energy. And then the focus as well in the project is a lot of this is done online. So how we can use mixed reality, extended reality, and immersive content to improve the learning experience for students. So we have something called a virtual campus, which is kind of an umbrella term for quite a few components within this project. But just because this is a 10-minute presentation, I'm just going to be talking about the immersive content, which is made up of 3D and 360 viewers. So what is the immersive content? Well, in the most kind of basic way, it's basically a 3D asset. And then these 3D assets are accessible on kind of any traditional devices like a laptop or phones. But then they're also accessible on XR devices, such as like a HoloLens or on a Quest in mixed reality or in virtual reality. So the main idea is that students, no matter what their device is, they will be able to access the 3D asset and view it in whatever immersive method is available on the device that they have. And then this means that everyone can see this content, but it also just another way to add more interactivity to online learning and hopefully improve engagement. So how do we create the immersive content? It's kind of 5 steps. It's kind of straightforward enough, but first of all is universities just identify the locations or the equipment that they want to capture. Then they use kind of relatively not too expensive devices to capture a video of this location or the object. And then the method we're kind of using for this project is they pass the video to us and we will do the generation and the optimization, but we are providing all the details for them to do it themselves. But just a big part of what we're doing is trying to find what's the kind of best value for time in the generation and optimization process. And we'll pass that on to the universities at the end. Basically, you can use this footage to create the 3D asset. Then these optimized assets can be available in a template library, and then the universities can choose which ones they want to create an immersive experience with, and then they can overlay PDFs, videos, images, and text around this 3D asset and sort of tell a kind of step-by-step story. So here's a kind of overview of the process. First, you record the video. It can be about 1-2 minutes long. And then you can use one of many free 3D model generators to get the 3D asset. Then we have this kind of easy to use tool where you can put the 3D asset in, and then you can position points where you add and overlay the content, learning content. Then here's an example of augmented reality. You can view this experience and step through it. So this is all done in a web browser as well. But the kind of, I guess, the real kind of best part of this really is just how much 3D asset generation from videos has improved over the past year or 2 years. Like if you look at that asset there, I guess if it had a shadow, you might actually think it's a video recording of the real thing. And I guess the best part is the file size for this is about 1.4 megabytes. So can be smaller than some images some people might share to you. So it makes it very accessible for people on phones and such. So here's an example of the viewer on a desktop. So this is a wind turbine at a university in Ireland. So video overlaid on the introduction. And you can see different aspects are highlighted and they can step through the process. Picture of the inside. And then here is a video again of a mobile phone. Same sort of experience, but then with a mobile phone, you can use augmented reality. So you can place the assets in the real world, and then you can get different points of views. So the idea is that these experiences, as they're just a kind of a URL link to access them, they can be embedded in a learning management system throughout a course, and just to make it more interactive. They can also be embedded or shared through social media links or advertisements to promote the courses and the learning content for these courses. Here's another example. This is like a 3-minute video that was shared by one of the universities, a piece of equipment. Same sort of thing, just to show an example. It also works like on a HoloLens as well, even though the device is not regularly used. But it's just because it's using WebXR standards. Most XR devices that come out now, they are supporting these standards. So maybe there's not too much interactivity in these experiences, but it's kind of a low bar of entry for universities to start creating experiences and rolling them out in their courses. And then as new devices come out with more interactivity and better ways to interact with 3D assets, these universities have this sort of catalog of assets that they can use. Actually, I didn't time myself now, so I don't know if I'm coming close up in time, but just going to highlight here is just on the left here is an asset that's, if you just use an app on your phone to generate an asset, it would turn out like this. And then we've played around with a lot of settings and the different ways of generating, and we're able to get a higher quality asset like this. So if you just follow the right steps, you can get very high quality assets. And then initially you might be getting an asset like this, about 81 megabytes. But if you follow the right steps, you can get this down to 0.7 for kind of an asset here that has very little detail and kind of shiny edges. There's just some assets that the university has been creating over the past few months. But yeah, that's it for me. Happy to take any questions.
All right, great, thank you. Good timing. Okay, and now we have this virtual presentation. So it means that I just need to make sure I'm going to share the screen again, but I need to make sure to share the sound, I think. Sound. And the people online, if you can please tell me if you can actually hear the sound when this video comes, that would be very useful. So I'll just play it for a couple of seconds first. Did you hear it?
Yeah.
Yes. Yeah. Okay, good. I'll keep playing it then. It's 9 minutes 44, so they're going to keep to the time limit.
Hello everyone, and welcome to our presentation on immersive technologies for wind energy. In this presentation, we would like to briefly introduce our company, explain how we found our way into the wind industry, and describe the solutions we have developed in recent years. So let's dive right in. We at Echtzeit are a small but powerful team of software developers based in Switzerland near Zurich. We have extensive experience in planning, 3D visualization, 3D animation, and simulation. We have also been head instructors at the SAE Institute for over 10 years, training computer game artists and developers in both Switzerland and Germany. In addition, we have extensive experience in professional game development for the AAA industry. What we do: we develop customized software solutions in the field of interactive 3D visualizations. We specialize in extended reality applications, including virtual, augmented, and mixed reality technologies. We are also an officially certified training center authorized by Epic Games for professional teaching of game technologies to companies. Given our connection to the gaming industry, it stands to reason that we also develop smaller games, especially for events related to gamification. Our many years of extensive experience with gaming technologies bring significant advantages to the development of real-time visualizations and extended reality solutions. Let's move on to our mission. Our mission and also our vision is to make this powerful gaming technology accessible to industry, whether in project development, product placement, marketing, manufacturing, or education. Gaming technologies can be used effectively in all markets, and we are committed to this. We also firmly believe in the enormous added value that interactive real-time visualizations bring to various processes. The visual communication of information in conjunction with interactivity and multi-sensory elements requires trustworthiness and an emotional connection to the project in many processes, which offers many advantages. But at the end of the day, despite all the technology, it's about people. That's why we want to use it to realize meaningful projects that really make a difference. And while we're on the subject of meaningful projects, it's only natural to move on to renewable energies. In the field of wind energy in particular, we have already developed a number of prototypes and finished solutions in recent years. For example, we have developed an augmented reality tabletop application that allows users to view wind farms from a bird's eye view and display shadow casting and wind directions. We have also developed a virtual reality flight simulator that allows users to explore a planned wind farm from a helicopter in an immersive way. Today, however, we would like to introduce you to our augmented reality solution called Wizard Go in more detail. Wizard Go enables the visualization of wind farms directly on site using mobile devices such as tablets or smartphones and offers many exciting features and functions, but more on that later. Wizard Go's journey began back in 2019 as part of a study conducted by the Zurich University of Applied Sciences. Researchers were looking for a tool that could realistically depict wind farms in order to mediate between supporters and opponents in referendums. After successfully developing and testing the first prototype, we have worked with various strategic industry partners over the past few years to support many real-world projects and continue to refine Wizard Go based on the insights and needs we have gained. We are proud to have released the second and final version of the application this year and continue to successfully support many projects in various countries. However, there were also various challenges that we had to overcome during development. It is important to be aware that the path to a fully functional extended reality solution that can actually be used and works in practice involves a number of hurdles. Such solutions are therefore easy to conceptualize but hard to realize. In addition to the accuracy of GPS, network, and data fundamentals, there are also dependencies on third parties such as turbine manufacturers or end device developers. Furthermore, there are limitations in augmented reality and hardware technology. Data security and the legal framework in different countries also play an important role in the overall picture. The good news, however, is that we have overcome all these hurdles and Wizard Go is already being used successfully in numerous projects. Essentially, the app can be used in all phases of a wind farm project. For example, in planning and internal project development, Wind farms can be easily and playfully created and managed in just a few minutes. The app uses augmented reality technology to visualize wind turbines in the correct location, size, and orientation, and to integrate them into the landscape on site. The app is also used in testing and decision-making phases. It allows users to compare different scenarios and turbine types in real time in a playful way, enabling them to make informed decisions. The most important aspect is the participatory processes, which the app can support excellently. As a visual communication tool, it is extremely helpful in exchanges with project partners, authorities, and, in particular, the population. Wizard Go Wind has already proven itself in these processes. In this short presentation, we cannot go into detail about all the features. Nevertheless, we will take a brief look at the three basic systems of Wizard Go Wind. First, we have developed a sophisticated account management system that enables organizations to independently create and manage users. Different roles and permissions can be assigned, and targeted access to individual projects can also be controlled. Furthermore, with our latest update, we have introduced a dynamic library system. In this system, turbines with the desired shapes, sizes, and markings can be easily created independently in a dynamic 3D configurator and saved within your own organization. These can then be used by all teams in their projects. But the heart of the application is the project management system. It allows wind energy projects to be created, managed, and customized in real time with various functions and visualized directly on site in augmented reality. In addition to the market launch of Wizard Go in wind energy, there are of course other possible uses for our framework. That is why we are developing Wizard Go as a product family, covering other areas such as solar energy, infrastructure, and architecture. We are very proud that we have been able to support so many partners and their projects over the past few years and look forward to many more. We are also already working intensively on the next innovations and improvements for Wizard Go, so things continue to be exciting. I would like to take this opportunity to thank you very much for your interest in our short presentation. If you would like further information, please visit our product website or contact us directly. We are always open to new ideas and exciting collaborations. Together we can make tomorrow's world a little better. Thank you very much.
Don't want to stop it until the music stops.
Yeah.
All right, great. Thank you to the people who created that video. No, so I'm in contact actually with them quite a lot. So if anyone's got anything specific they want to ask or talk to about, I can get you in touch with them. And then the final amazing presentation is from me, and I'm just going to present a project that we're doing at Oslo. I actually think something like this echt site solution might be useful. So let me just try to find my slides. So yeah, we have a project called CodeWind at my university. It's about collaborating and dialoguing with the local community on future wind energy projects. And in Switzerland, it's quite a big problem, the acceptance thing. Is it okay?
Yeah.
So the goal of the project is to develop something called a digital co-design framework for facilitating collaboration and dialogue on future wind energy developments between local municipalities, government stakeholders, and wind energy experts. the focus is on the potential environmental, social, and economic benefits. And the idea is to have a standardized framework so that people in the future can apply it to different regions of Switzerland. And again, the problem is in Switzerland. Anyone want to guess how long it takes to develop a wind energy project in Switzerland?
How long?
Guess. Okay, I'll give you a reference. It takes about 5 years in lots of countries.
7, 10 years.
25, and they've just introduced a wind express, which takes 23. That's the express. No, there's quite a lot of political barriers to do with the way the systems, the politics works in Switzerland, which means that people can block projects at many stages, and so they're pushing quite a lot on this acceptance issue and how to get the local communities involved more. And so the idea of this project is to develop like a digital tool for community engagement that helps integrate different stakeholder needs in wind projects. And we hope that this will also result in us better understanding local perspectives and concerns, and also to introduce a community engagement process for different people to follow in the future. And then at the end of the day, improve their ability to maximize social, environmental, social, and economic benefits. And then just to understand the application potential of this thing called applied category theory, which I'm going to tell you about in a minute. This picture is just showing the partners. So it's funded by the Swiss Federal Office of Energy. Oslo are leading it. We're working together with Wageningen University and Research in the Netherlands. And then we have quite a few companies. We have a local company who's going to work together with us on a specific project, but then we also have some advisory board in Switzerland and beyond. And so this thing about code, I use the word co-design. What do I mean by that? So there's this actually, people who work in social sciences know this thing called co-design, which is actually just involving lots of different parties in the design. But there's actually a different thing, a mathematical theory, which is also called applied category theory, which is, it's pretty mathematical, but it's actually about creating these things called design problems through a functionality space, in an implementation space, and resources space. And you create these things called monotone co-design problems. And actually the main point of it is that you can optimize things that are not directly quantifiable. So usually if you think about optimizing a wind energy project, you're trying to, let's say you've got all your wind turbines, you're trying to reduce the wake effects, you're trying to optimize the energy, but reduce the loads at the same time, right? They're all numbers. What happens if you interview a local community and they say, well, I kind of like to have a wind turbine that's not too big and I don't want it to be too noisy, but I prefer it to have some improvement for the tourists, but I don't want the infrastructure to be used too much. And they have all these vague things that they say, right? And it's not quantifiable. And what you can do is that you can put, if you get preferences out of these interviews, so generally people prefer this and this and this, and you order things, you can then include them in the optimization in this theory. So the design space can be discontinuous. The objective function can be non-scalarizable, so you can use community preferences. And you can efficiently search for new optimal solutions as the preferences change as well. And I think, as we just heard in the previous presentation, there is this need to include the communities in the procedure. We're not working with them at all yet, and we're not working on any immersive technologies. But the idea is that we have a framework where that can be done. This design can be done automatically and also updated as people's preferences change. And so, just as a very basic example, you can set something up where you have this design space where you have, like, example, high yield, low yield, large quiet, large noisy, small quiet, small noisy, and you have different development costs, you have different investment horizons, and then you can connect all these different things with each other in ways that you define. And so, for example, you can say it's impossible to have high returns with short-term investments, or that the only way to obtain high return is to install large and noisy turbines, and you can see what options are even available. And then if, for example, a local community then see, okay, if I want a turbine that I can't see, it's not going to be there, then I'm not going to have a turbine. I'm not going to get any of the benefits that I'm trying to get. So it's also a way to visualize all the different requirements. And so the framework is sort of aimed to look like this. So we have this framework, and the idea is that in this framework we provide guidelines for creating these structured interviews. But the idea is what comes out of that are then this semi-structured information in some sort of preference, and some with preferences somehow. Then you can also do document analysis. Like usually, if you have a wind energy project, you have certain documents provided about the project or about what's happened in the past with the project development. And then you define this thing called the co-design problem. And to do that, you really have to define the functionalities. So like, what do you want it to do? So I want it to create energy, for example, or I want a certain return on investment, or I want a certain increase of tourists, or I want a community project to be built or something. And then you define the minimum resources required, so the minimum amount of investment that has to be made, or maybe you've got some land available. And then you define this optimization problem, like what am I trying to actually optimize? And then in this model, you can then display the different results, but the point is that you can iterate on it. So if somebody in the community then says, well, actually, I've changed my mind, I actually don't mind what it looks like as long as it stays below X decibels, and then you can show them what the effect of their change of mind would actually have. Or if they say, no, I don't want it to be big, and I don't want it to be noisy, and I don't want to be able to see it, then you can show them, well, okay, the result of your project is you're not going to have a project anymore. Or, something you can visualize it, and you can help people to make informed decisions. And my thinking about this is that I think that this could actually work together with some AR or VR project. So this is actually a picture from the Echtzeit website, where if you have this type of optimization where you've come up with some design of wind farm which somehow puts these preferences in the right order, then maybe you could combine that with an app that's actually then displaying it, and then you go back through your iteration, and if it's clever enough and fast enough, it can then update, and the people can actually then see what's happening. The results of our framework at the moment isn't going to be people seeing turbines. It's going to be some numbers and some graphs. So it'll probably make it more accessible and understandable, combining it with these technologies. So that's basically what we're doing. If you're interested in the details, I won't talk about it too much, but this is a high-level abstraction of a co-design problem, where for example, the green things are the functionalities and the red things are the minimal resources. So we're basically saying we have this local community who have certain tolerance limits. So there's a certain area they want to take up, or a certain noise level they don't want to exceed. And there's certain site availability. And then there's certain benefits that they might have, but there's also certain political mandates. And then you have the wind farm project itself. And actually, what's interesting is that some of these functionalities from the community turn into minimum resources for the wind project. So if there's a tolerance limit about how much area or noise the wind turbine is allowed to produce, and that turns into a maximum for what the project should be then delivering. You have some sort of revenue that you're hoping to get. And then you have your benefits that the wind farm project brings. And so you can make this map. And actually, if you look at it in more detail, like this picture is not meant for you to be able to read it, but just to show it gets very detailed and complicated, because you start thinking about all the different impacts, health impacts, or energy independence, education opportunities, and the different benefits that people could have. And then you have the different things that affect the site itself, and then you somehow have to map them all together. So you actually end up with this design problem which has lots and lots of aspects in it. Some of them are technical. Somewhere here you have the energy production. Look, it's here, but you have also lots of all these other aspects. And what we're doing now is basically coding that, so that people can then put once we've done some interviews, we can then put the preferences in. So yeah, that's it. My idea is just to talk to companies like Echtzeit or others to work out how to work together in the future once we've actually got an algorithm up and running. So yeah, if you want to know more about that, then get in touch with me. Otherwise, I've finished, and now we have 2 minutes. Now we can go a little bit further. So let's open for questions. So has anyone got any questions for any of the speakers? I have one, but I'll let someone else ask the question first. Oh, Sarah had to leave, so if anyone's got a question for Sarah Colmus, then we have to ask her later. But
I think one question for Charlie, it's about the models that you were showing. Are for example, if suppose I have to use it in my teaching, are these free resources or do we need to pay? How does it go?
Well, the assets that are created by the universities, they're just sharing them among themselves. But the type of asset that's being generated is a Gaussian splat. So there's plenty of free resources to generate them. And there is different types of viewer applications for various devices you can use to view them as well. We've developed a kind of custom one for the universities based on their requirements. So that's what we're using. But yeah, if you want to talk a bit about more, happy to do it.
Yeah, thank you.
can you, Charlie, while you're there, my question that I was going to ask was for you. Is the accuracy of your models actually high enough to get the blade geometry?
I guess it kind of depends on the scan. If you just focus in on one blade, I don't actually know the quality that you need for the.
Yeah, like millimeters.
No, I don't think so.
No, it's just that it's not really anything to do with this topic, but well, it kind of is to do with immersive technologies. Like one of the big problems of creating digital twins, like we work on open frameworks for digital twins. So in Task 43, we work a lot on open data and sharing and making things more available. And one of the big problems is of digital twins of wind turbines is that you don't get the geometry. That the OEMs are not going to give you the geometry of anything. So that people have tried to like do 3D scans of the blades and stuff. It's obviously possible, and the OEMs don't like it. And so I was just wondering if this technology was accurate enough to get anything reasonable. But okay, the conclusion is that it's not really accurate enough to do to get the full geometry, but it might still be accurate enough to get a vague idea of it.
Yeah, definitely. It just keeps getting better as well. So who knows in the future? But it's more of just a visual element to use in a learning experience at the moment for us, at least.
One question, Marcus, about these, because Google is coming up with these Genie 3 like world models. So
yeah,
where do you see and in comparison to these Gaussian splats? I mean, is it based on same kind of thing or?
So the Genie, that is a technology where you write in, you want a
prompt,
a fantasy environment of, I don't know, medieval forest, and then it generates video data based on that.
Yeah.
But I think it generates actual video data. It doesn't generate 3D data.
Okay.
It generates, I think it says in the article, 720 pixel video data. So I think the next step or the step beyond that would be that it's actually able to create VR data.
But isn't navigation allowed in this? They say that you can navigate.
I don't know.
Yeah, because if you see Genie 3 in here, so they are like
they're moving through. Yeah.
Yeah. So yeah, if you see this, I mean, just with the help of cursor, you can go in either directions. Yeah.
Yeah. But I don't think is it VR?
No, it's
actually,
not.
Yeah, it's not VR yet. So you just have the monocular one view.
Yeah.
Give it a year or something like that. AI is moving so quickly.
Yeah. So that's good.
Any other questions? If there aren't any questions, I'll just move on to the next part. Well, we're on time to do the next part anyway now. So what I'd be interested in talking about is what can Task 43 do? Like, what can we do with all these interesting presentations and this information? Now we kind of know what the need is, and we kind of know what state of the art is. Is there something that Task 43 can contribute, and if so, what? And in order to do that, I want to quickly tell you all what Task 43 even is. You can effectively answer the question if you're not part of Task 43. So IEA is the International Energy Agency, and they run this series of tasks in different topics. And so there's this thing called the IEA Wind Technology Collaboration Programme, which is an international collaboration of 24 countries that share information and research activities to advance wind energy. What it doesn't do is provide funding. Well, it provides funding, a little bit of funding for the organisers. So like I co-lead Task 43, it means I get a little bit of funding to cover my organisation time, but they don't pay research funding. And the general idea is to say, okay, the EU has got its research funding, the US has got its way of funding, but there's no way to bring them together. So the idea of these tasks is to say, well, we want to advance wind energy research and innovation. Let's try to work together. The only way it works, because it's not funded, is that we find things that actually where people have mutual benefits. So we try to find topics where people say, okay, I'd really like to develop some best practices on this topic, or I'd like to learn from other people on this topic, or I'd like to write a paper together that actually benefits the people. So like trying to force somebody to collaborate voluntarily on something doesn't work. And so you have all these different topics, and anybody can suggest a topic as long as they get enough people interested. And so you can see there's quite a wide range of things. Most of them are quite specific. Task 43 is quite broad. And so in Task 43, we're looking at digitalization, and we're trying to unlock the full value of wind energy. And we want to act as a digital transformation catalyst by driving open collaboration. And we want to deliver insights, recommendations, standards, and tools in these three areas of data, culture, and competition. And those three areas come because we wrote this has been running for 5 years now, and the first 3 years was phase 1. And we wrote this paper called The Grand Challenges of Digitalization of Wind Energy, where there's basically a load of interviews and research done to try to work out what the challenges are. It's probably changed completely now. But the main idea the result was that, okay, the first challenge is this whole thing about data structuring, data standards, fair data, if you know about this fair data world, and then culture. So like, how do people and organizations create environments which support the development of the digital transformation? And then this thing called competition, which means competition and collaboration together. So how can other organizations push each other to become more innovative? And that's why we focus on those three areas. And so we have this structure where we have basically these three working groups which all interact with each other. We have a use case demonstration group which attempts to use some of these things that we're developing in real projects. And then we have a task management who tries to get, as well as disseminating and coordinating, we actually try to get the needs of people from the industry. We don't just want to do something random. We want to do something which actually helps people. So that's the general idea, and we're writing a new extension proposal, which will start next in a year, basically. And we are looking for other topics. So we're probably quite going to go in the direction of AI, making data AI ready, and all that business. And then basically Arvind came along and said he's really interested in collaborating. He wants to push something on immersive technologies, and we feel like, okay, it fits somehow in this structure. In this working group too, we already have a group working on skills. So we have a group looking at they're actually doing like skills mapping. So they're looking at different tasks that people in the industry do and saying, okay, what skills do they need using the old way? What skills do they need? Do they need using new tools? So for example, for wind resource assessment, with and without we've developed this data model, and we look at what skills do they need without if they're not using this data model, and what skills do they need if they are using it. And then the skills are different, right? And then we come up with this gap. And we're actually developing a framework to do this for different tasks. So maybe this framework we could also apply for some tasks where immersive technologies are used. So again, if we're going to do something in Task 43, it basically has to be something where you people listening have a benefit. So what would you benefit from? What's missing? Like, is there something like just learning from each other about the state of the art because the technology is developing so quickly? Is just hearing the state of the art like a thing that would be beneficial, or do you feel like a group should be developing some sort of open tools or models or standards or some recommendations how to use immersive technology and wind energy could be a thing that could be developed, if that would be useful? And so I'd just like to get inputs on that. I like to do it on Mentimeter because it's a good way to record what people think, but obviously people can just speak as well. I see that some people have dropped off now, probably they have a 3 o'clock meeting. But actually I'd like to start with Arvind. I mean, maybe you can just say something like, because you're the one who's kind of initiating this. Like, do you actually have some concrete thoughts about how you think an international group could actually, what they could actually do and how people could benefit from doing that together? Sorry to put you on the spot. I didn't actually warn you I was going to ask you that.
It's okay. I mean, after presentations today, and I think 4 months ago in Norway, a city called Hamar, there is a school which is a gaming school, right? So they also build a lot of VR, AR, these kind of immersive technologies, right? And when I talk to them, so they are like, okay, from the research point of view, because energy and with this digital transition, the EU and the Green Deal, so there has to be the confluence of the digital technologies with these energy transition, right? So we know the future is digital and the future is this green energy. And so they had a lot of use cases related to, for example, fashion industry, but they were lacking their expertise within wind energy, just like, for example, you guys are an expert. So if we have one of the groups working on immersive technologies, so let's say it means that it's like, again, as the task 43 is doing, people from different expertise which are sitting with their silos. You have a lot of information of VR and these technologies, and let's say you are an expert in wind, so we just sit together. For example, in today I met you and I met Sarah, so and then you start to build on, and then you have some projects starting from bachelor's, master's, etc., or even writing some proposals together. And so that would be one. And as I said, my experience is only 1 year in this technology, but I see a lot of traction, a lot of interest from people. And with this, the DigiWind course as well, I think these guys have, even EU has a lot of funding opportunities. They have something special called, which is currently available, which is called as virtual worlds. So even at that level, so if the people at the commission are thinking that there is something happening at that level, then I think having more of this NGO style of cooperation that we have here, right? For the public, you are doing everything for free, because if everything is behind these paywalls, then the research doesn't move as fast as it could. For example, AI, right? Most of it is open source. Definitely few companies are making money out of it, but again, you have access to everything. So I think so in that direction, it's a good step. And I would be happy to be part of it because again, it's my personal interest as well. It's cool. And with my daughter showing her everything here, it's also because the future is about technology. This Gen Z, I don't know, Gen Z, Gen Alpha, you cannot separate technology how it is. When I see like 5 years old, you are on a dinner table and, when you want them to keep shut, give them a technology, right? And if you see in the future, it's more about embedded technology as well, right? So this is, education will change. And I think it is, if you want to educate people, it cannot be the traditional classroom setting. People feel bored. To capture the attention of the young generation, you need something which is more immersive, which is more, technology is the key, right? I don't know, just like Instagram, there could be some Windygram where you're just telling 1 minute shorts. So some stuff. So it is the future, I think so.
I don't know, Charlie, if you can say something about the DigiWind project. Like it seems like what you're producing is specific to the DigiWind project. Like you mentioned that before when someone asked a question. Are you thinking more like this idea of sharing more and being more open as opposed to finding specific solutions for specific customers? Like it's always a bit of a weighing up the best way to do that. Like what are your thoughts about that?
Yes, so there are some applications we're developing that are more bespoke to specific use cases. And there's another partner called CAD People in the project that focus on that as well. I guess what I shared today is just because it's a large project and there's meant to be a lot of eyes and a lot of students attending, we were just trying to find a low bar of entry to kind of scale out immersive content. And the only way we thought to do that is, I guess, is if the teachers themselves are producing some content, and then the kind of these kind of Gaussian splat approach of just recording a video on your phone and you get a 3D asset, and then you can already put your learning content over it, and then it's just shareable through a web link, so anyone can kind of view them on whatever the device is. It's just kind of an approach that would hopefully get people more familiar with immersive content, and encourage them to sign up to the courses to then get access to the kind of paid, high quality, kind of bespoke immersive experiences that are kind of expensive things to develop.
Okay, let me finish asking the rest of the questions on the Mentimeter, just because we're about to run out of time. So which applications are most interesting? So people have said data visualization. That's also one that we didn't talk about really. Transparency, education, training, visualization, engagement. And then I have to start the question in order for people to answer. What would you want to achieve in a working group? So it'd be quite good just to get a feeling of the priorities. Do you guys want to take part?
This is dead, so
you can also have power if you want. Oh no, Dara's using it.
I think I do.
Yeah. Learning new things. One person wants to learn new things, and no one else wants to do anything in a working group. What do you think? I mean, have you come across these type of working groups before with certain? What would you want to achieve in a working group like this? Maybe it's not relevant for you in particular.
So you cannot multi-select. There's just.
Oh, okay. Maybe I put the setting. Yeah,
I want to do multiple things, but.
Maybe I put the wrong setting. Just do one for now. Sorry, I could change it, but I don't know whether it's worth.
Yeah.
Worth it in this.
Starts the whole thing if you change it now.
I won't risk it. We'll just say the highest priority. Developing standards together, learning new things, meeting potential partners or clients, sharing experiences and challenges, writing project proposals together.
Nobody wants to write paper.
That's academics versus industry.
Exactly. That we are anyhow writing.
Yeah, I mean the grand challenge is of digitalization of wind energy is really good paper, and even for industry people, there were industry people involved in it as well. Like it was pretty good, and we also wrote one on knowledge engineering wind energy, which I would say is pretty interesting for industry as well. But yeah, it's only the academics who actually want to write it. The others want to just get other people to write it for them. What would make you participate? I think I put an open-ended question in there.
Yeah.
And don't say funding because you can say funding. But like, what would we have to do in order for it to be interesting for you to actually participate in a group? See, lots of people have dropped out now. So my interesting partners. The survey is not going to be very representative. Did you write that?
Yes.
Anyone else want to write anything? Everyone wants to go to the next meeting, probably. Exciting, fun, cool. Oh yeah, okay. No pressure. I'm going to write a proposal to IEA Wind. We've got the most fun, exciting, and cool topic, and that's what everyone's saying that they wanted. It's actually not such a bad thing. Real world relevance. Interesting collaboration, exciting. Yeah, it's good. I'll take that away as being cool and fun is important. The trouble with the word cool is like completely relative. I understand fun and exciting, doing something new, adding value. All right, cool. I better stop because it's we're already over time, and probably the people online have got better things to do except for sit around here watching us eat food. Does anyone want to ask or say anything before we close? Online? All right, well then, thanks for attending and thanks for listening if you're online, if you're listening to the recording, and thanks to the speakers. I think Charlie's the only one who's still here online, but to you too as well for taking part. And yeah, thanks, and hope let me know if you want to get involved or you've got any questions. Otherwise, I'll send you a link with the recording in as soon as we've prepared it.
Thank you, folks.
Thank you.
Bye. Thank you.
Thanks, everyone. Bye-bye.
All right.